Let's take a look at the seat lug area. Right in here, you can see that we have quite a gap in this area, and this seat stay is lying up nice and flat against the seat lug. This one we can move over and force if we want to, but we don't want to have to force it. Rather than forcing it, let's look down here at the dropout, at the tab, and what we'll do is we'll take the seat stay out of there and put a crescent wrench on there, and we'll give it just a little bit of a bend. Don't give it very much of a bend. We're only talking about a degree or two there. A degree or two is just enough to get that seat stay up here to hug the sides of that seat lug. And we're looking just right now. It looks excellent. Alright, let's take a look at the right hand seat stay. Notice that this side is longer right here. This side is shorter. This is the inside surface. I've scalloped it out of there to give more relief for sprocket clearance. Notice that I've also left these little tiny points right there and right there. Those little tiny points will keep the seat stay from falling off the edge of the dropout during the brazing process. This is why I always finish my right hand seat stays with that extra little bit of clearance. In finishing the seat cluster, I'm going to be doing it with a pair of flat plates. However, I want to show you another option in finishing seat clusters. Right here we have a plug that we can put into that seat cluster. It's round and it's already scalloped out right here, basically pre-finished, and you might have to take down this surface a little bit, enough to get it to go into the top of the seat stay. All you have to do, these are really easy to fit. All you have to do is take a look at number 1, where the end is now, and number 2, where you want the end to be, right there, and just measure the distance between the two. Where I am to where I want to be is 120 millimeters. So from here to where I want to have that end is 120 millimeters. All you do is you chop 120 millimeters off the tube, stick that piece in, braze it in, and clean up your joint, and it's all done. Very, very easy to do. However, what I'm going to do here is I'm going to be doing flat plates, which are a little bit more difficult to do. I'm going to be doing a partial wrap around. Just from personal experience, the tangent is, I'm going to put a T right there. There's a T, and the top bar of that T, same thing over here, the top bar of the T is where the tangent is, right about there. And I'm going to cut this thing about 5 or 6 millimeters above the tangent to do this type of fitting. So that's just from personal experience. When you do these, you're going to have to kind of shoot from the hip and figure out exactly what you need to do. But I'm going to cut about 5 or 6 millimeters above the tangent. First of all, we're going to take some blue layout dye. You can use either blue or red layout dye. They come in 2 colors. I don't know why I buy the blue. Just form of habit. We're going to highlight this area with blue layout dye on both sides. You use blue layout dye so that when you scribe marks, they show up much better. Might want to blow on it a little bit, get it to dry a little faster. Then I take a file, just flat file is fine, and I hold this file carefully so that I'm hitting the tangent of the outside of the seat stay, and then just run your file down like that. Till you have a line scribed, right? And that line will be scribed on the outermost portion of that seat stay. And we're going to do it on the other side. So we have a line scribed on the outermost portion of both of those seat stays. Now we're going to rough cut our angle on the outside. Okay, what we're doing here is we're cutting part of our piece off so we don't have to work with, so we don't have to grind the whole area on the belt sander. And I'm cutting out a piece, kind of a piece shaped like the visor of a hat. Don't try to get your whole taper all done. I just did that to lessen my work on the belt sander. And if you can see this, you can see that my line that I scribed with the file goes straight up away from that cut that I just made. And now I'll do the other side. Okay, here's our piece, and this was the one that the file mark that I made did not come out of the center of that scallop, and I was able to adjust as I worked the belt sander, and I've got that file mark coming right out of the bottom of that scallop. Now let's see if we can make the other one exactly the same. Okay, here I'm working on the second seat stay top, and what I'm trying to do is if I can get this oval shape the same length on each one, they'll match. I've got 38 millimeters on the other one. Right now I'm coming pretty close to that. I got 39 on this one, so I'm going to take a little bit different angle cut, shorten it up, and I should have it. I've gone a little bit long on this one, so I'm going to go back and get the other one. I'm going to take, this one is now 40, and I can't really shorten it up, so I'm going to take the other one and I'm going to lengthen it a little bit to match this one. We have our angle piece cut. One of the things we're going to have to do is we're going to have to take this piece of flashing out of here. We can do that with a jeweler's file, and then we've got some flashing up here that we'll have to remove. Now, one thing you're going to have to be very careful of when you remove this flashing is don't alter this sanded surface. This sanded surface, this oval shape here, is as flat as you're going to get. Do not touch that surface with a file because it's not going to be very flat by the time you get done. So just carefully remove that flashing. Jeweler's file and sandpaper will do it fine. Let's change to a different angle and look at this from the back. If you take a look here, you can see that the tops of our seat stays are the same length. If one was taller than the other, it would be a lot easier to go down to the slot at the dropout and cut that slot deeper to adjust for up here than it would be to try to mess with that oval anymore. Also, you will notice that, well, you might not notice it on the TV screen, but I've been able to notice it here, that if I sight from the back of the bike along this surface right here, close one eye and do that, and sight along this surface here, that my flat surfaces are pretty much in complementary positions. I'm not rotated like this. They're nice and flat against the side of the seat lug. Now we'll go to the vise and we'll cut some flat plates to go on top of those seat stays. What I've got here is a couple of rectangles cut of just 1/16 inch thick cold rolled steel, nothing special, and those are going to be brazed right onto that oval shape. I've removed any of the burrs or flashing from the edges with sandpaper. I'm going to flex this surface up. Again, this is silver solder. And at the same time, I'll flex the other one up. And I'll take one of these pieces and just set it in place so it's even on each side. This other piece we'll set on this one. Incidentally, if you want to do something really flashy on the bike, instead of using just plain ordinary cold rolled steel, go ahead and use some stainless steel. I have an old restaurant tray that I clipped apart, and when someone wants stainless steel in these areas, I cut a few pieces out of that restaurant tray. I make these same pieces out of stainless, and then I can file them smooth and sand them out, and even buff them right down to jeweler's rouge. We're going to tack right under this side. This is not a very long preheat. Just a matter of seconds and it's ready to tack. There's our tack. Once we get our tack, we can turn this thing over. You can see now why I advised you not to touch that sanded surface. Because if you leave that sanded surface alone, you've got a nice matching mating surface for these pieces of plate. And I'm just pulling that silver in around that oval area. If in doubt, use a little bit of extra silver. Make sure you get your silver under all the way around the edges. This is a difficult area right here at the bottom. Make sure and get it right underneath that. Okay, we've got that all the way around. Take the other one. Do exactly the same thing. There we go. We have our two seat stays with our top plates brazed on. They look pretty ugly at this point, but the next thing we're going to do is we're going to file around carefully and remove that excess. We're going to be making sure to do all of our filing tangentially to the tube. Just a quick announcement that this is a red letter day in the Paterek frame shop. It's been about 10 years since I've changed the soft jaws on my vise. You may have seen in the last scene that they were literally falling apart, so I took about 10 minutes to make myself a new set. This is a brass set right here. This is just a brass off of a door plate, one of those push plates that you push with your hand on a door. Cut it in half and just bend it over with a hammer, and we have a new set of soft jaws just like that. We're going to stick the seat stay in here. Notice that I've just briefly roughed it in on the belt sander without touching any of the seat stay material. Also, I've cut this to a rough point with the bandsaw. I cut it with the bandsaw like that, so that this cuts down the filing I have to do by quite a bit. Remember, all of our filing on this is going to be done tangentially to the tube. So we're always going to keep this file at a tangent to the tube. Our point here is to remove as little material on the tube as possible. We're going to be removing our material, of course, from that flat plate. And we're just going to keep going around in a circle here. And back in here we have quite a silver buildup that we have to file through. Notice at all times I'm keeping that file tangent to the tube. Need to be careful how tightly we grab back here. We don't want to collapse our seat stay. And those of you that don't have soft jaws in your vices, I hope you put them in there before you got to this stage, because you've got a lot of teeth marks in that frame by now if you didn't. About halfway through this process, I switched to a 6-inch flat file so I could have a little bit finer surface before I started with my sanding. Now I'm using a 100 grit emery cloth strip, just sliding it underneath my thumb. I'm being very careful not to round my edges. I'd prefer to have nice crisp lines around the edges rather than rounding them. I think the nice crisp lines are more attractive to look at. Here's the other one. The other one's finished. I think that looks really pretty. Completely smooth, very satin type finish. You'll notice that the point goes beyond the end of the top of the seat stay, and that's going to be a partial wraparound. That point's going to be bent over a little bit. So let's go over to the frame and see how these points are going to get bent over. Here we have the finished seat stays, all in place, same length on the ends. However, the ends are lying up away from the seat cluster. So what we want to do is we want to pull them out and put a little bit of a bend in the end, so that those pieces now lie in tight against the seat lug. Maybe a little bit more. This is a partial wraparound seat cluster. If we wanted to make a full wraparound, of course, this point would go up about another ½ inch or so, and the two points would meet in the center of the lug. Just put a nice gentle bend in the end there. There we are. They lie right up flat on the seat lug. Now the next thing we do is we need to mark where some air expansion holes are going to go. So I'm going to mark them right up under here where they're going to be out of sight on the underside. And then down here, about 1.5 inches up from the dropout joint on each side. So we have one here, one here. 2 air expansion holes in each tube. This allows not only for expanding gases to escape, but also allows the solution, the metal prep solution, to go in and circulate, and then you can get it back out again. Here we are drilling the air expansion holes. We're doing a 7/64 air expansion hole in each end. As I did earlier, I marked these holes with the automatic center punch made by Starrett. Always remember, make these air expansion holes in an area that's out of sight. They would look rather unsightly to be out in plain view. And after we get these done, we'll clean up the bottom end of the seat stays with snow bowl. The inner surface needs to be soaked in snow bowl right up in there. The top end has been completely sanded. It's totally clean. The seat lug is totally clean. It's been completely sanded. However, the chainstay, the dropouts down at the top of the dropouts are corroded right now, and they need to be cleaned and snow bowl also. As you recall earlier, we stuck our die grinder inside this socket and opened it up so the chainstays would fit. Same thing on each side, and of course that left some pretty heavy burrs along the edges here. So I took some 1-inch wide emery paper or emery cloth sanding strips, and I've sanded away all that burr and cleaned up this edge so it looks nice. Another thing you'll notice is that we have a long point over here, but I've chopped it short over here. And the reason I did that is this is going to be a touring bike, and we're going to have a granny gear right back in this area, so I want a little bit more clearance for that granny gear. So I've cut almost a centimeter off of this side. If you're making a racing bike and you have a real short rear end, what you want to do is you can leave the outer tips the same length, and but I cut the insides off and round them off nicely. That way, when you put your chainstay bridge in place, it won't jam up against these points before it bottoms out against the chainstays. Those are some little hints for working with a Henry James bottom bracket shell. We're going to go and clean this up now. These sockets are pretty clean. They've been ground pretty clean, but I can see a couple of black areas. So we're going to go clean this up along with the other pieces for the rear triangle. We're all ready to do the brazing in the rear triangle. Let's take a look here. I've got everything reassembled with the flux all in place. Last thing I have to do here is I'll take a toe clip strap and just slide it down. That holds the seat stays together up here. My brazing points are right here. You can see I've got this all fluxed up. Both the mating piece, all the mating pieces are fluxed. If we slide down the seat stays, we can see that our top tab on the dropouts are completely fluxed. And then if we go forward to the front of the chain stays where they enter the bottom bracket shell, we're all fluxed up here. And the order I'm going to do this in will be dropouts first, then I'll do the seat cluster, and then all I'll do is I'll tack the bottom bracket shell. And the reason for that is I'm using vertical dropouts, and I may have to extend the length on one of the chainstays to accommodate a longer or shorter chainstay. As I mentioned in the last shot, I do this joint first. I always do the dropout joint first. What happens here is if you do the dropout joint later, you have the tops of the seat stays attached, and then you come down here and you find out that you've got a gap between the dropout and the bottom of the seat stay. And of course, when it heats up, that gap will close, the silver will fill the joint, and then when it cools down, it'll pull the dropout up, and you'll have alignment problems. So always do the dropouts first, because the seat stays where they attach at the top won't give you that problem of heating up and expanding toward a gap. Okay, if you're good at this, you can do this uphill and just suck that stuff right up inside. I'll tip this jig upside down in a few minutes, and we'll fill them up from the bottom side too. I mean, from the bottom side up. Don't forget, your dropout is considerably heavier than your seat stay, so we're putting about 80% of our heat on the dropout. Also remember that silver always follows the heat, and we can literally get this silver to move uphill for us just by careful manipulation of the heat. We're watching all those signs as before. The heating up of the flux and the bubbles and the disappearance of the bubbles. Right now they're gone and it's ready. Okay, we're going to turn this thing upside down, and we'll fill the joint up the rest of the way from the top. You may have noticed earlier that I did remove the frame from the rear end fixture. If you've got a good fixture that'll stay all in adjustment when you remove the frame, that's definitely a plus. This particular fixture will allow you to remove the frame completely to do some fine-tuning or some cleaning up or preparation work, and when you put the frame back in, it'll be all within tolerances. Okay, now we're filling that gap, that little crescent-shaped gap. Filling those gaps is kind of a careful balance between the surface tension of the silver and the melting point of the silver and the heat of the metal. Okay, we go back to this one. Obviously, reheating time does not take very long, because just a couple minutes ago I had this up to temperature. It has not cooled down very much since. And we're already here, shoving that silver in. You have to be careful on these. If you want to, you can dump a whole ounce of silver down inside these tubes. So you have to, kind of from experience, know how much silver you want to dump in here. I'd say about 3 inches per side should finish this joint quite nicely. 3 inches for the left joint, 3 inches for the right joint. Okay, I'm going to tilt this a little bit so the seat stays are lying flat, and I'm going to fill this. There's a little bit of a crease up here, and I want to fill that while this stuff is still hot. The reason for that is I'll come by here later and I'll file that clean. If I don't fill it right now, I'll have that unsightly crease, and when it's painted, that crease will be quite noticeable. Just a dab of silver to fill that. Okay, let's do the seat cluster. Here we have to be kind of careful. We've got a lot of stuff that's held together with silver solder, and of course, if we overheat in this area, we could have one of these plates drop off of the top of the seat stay. If you're really not sure of yourself in doing these setups, you might want to braze these. Remember these plates we put on? You might want to braze those on with brass first as a sub-assembly, and then when you come here and do the silver soldering, you won't have to worry about those falling off. I'm used to working with silver enough that I'm confident that they're not going to fall off on me. Preheat time doesn't take very long here. We're already up to temperature. This joint has to be a finished joint when I get done brazing, because I'm not coming in here to clean things up later. So this is going to take some skillful manipulation of the silver. It's going to take some skillful work with surface tension to hold things in place. If you get things too hot, a whole bunch of silver is just going to drop out and land on the floor. So you have to hover at the right temperature here. One area that can give you a problem in this joint, and I usually try to take care of that problem at this stage, and that area is right up on the top, right on the top rim, right here. I usually take and drop just a little extra silver right around that top rim, because heating up down here is going to pull the silver down, and it'll pull the silver down out of that top rim, and you'll have a little bit of a crease there. But if you heat up at this point and drop a little extra drop on top, you can clean that extra drop off. We're going to finish up the other side here, and then we'll flip this thing upside down and we'll finish the bottom side. Then we'll flip it one more time and we'll re-inspect the top. Of course, the top will be a more visible area, and we want to have the top looking nicer than the bottom, because when people scrutinize this bike, they're not going to look at the bottom. Don't forget that the tubing here is the thinnest of anywhere in the frame. This right down here, the seat tube, this area is the thinnest in the whole frame. So, you know, don't wander with your torch and don't dally. If you happen to accidentally sit on that seat tube for too long, you'll burn a hole in it. So stay away from this area right here. When you do this joint, you'll find out how important surface tension is. It looks really nice all the way around there. Let's scoot this stand a little bit. Do the other side. You got a careful balance going here between the heat of the top of the seat stay and the heat of the lug. They need to be balanced quite carefully. They both have to be at the same heat. If the lug is hotter, the silver is going to jump toward the lug. If the seat stay is hotter, the silver is going to jump toward the seat stay. So make sure that you're keeping all this stuff the same heat. That's the same temperature, and that's one of the big tricks of frame building. Okay, we're going to flip this thing again, and we're going to inspect that top. That top has to be inspected with the joint being level. So let's lay this thing so that seat stays are level. And we'll just reheat here quickly. I think it probably will be okay. Just reheat. You can't inspect this without reheating. You can't look underneath this flux after it cools. The flux really masks the joint, so you can't see things. You definitely need to reheat and get that silver just slightly molten again so you can inspect it. We got a little bit too much silver near the front of the joint, so I'm going to heat up and move it to the back of the joint. Those of you that have good sound on your systems while you're watching this, you might hear the shop cat. The shop cat is wandering through the shop at this time. He keeps an eye on this operation. He keeps under quite close watch. All shops should have a shop cat. Shop without a shop cat just isn't much. Okay, that's a totally finished joint. I will do very, very little cleanup in that location. Okay, we're going to do our final, not our final, but we'll do a fairly sizable tack on the chain stays. I'm going to do this on the top side, and the reason I'm doing just a tack here is so that in 20 minutes or so, when this thing cools and I stick a wheel back here, if one chain stay is shorter than the other, the wheel will sit to one side more than the other. If I have just a tack here, I can warm up that tack and move that chain stay in or out as necessary. If I finish the whole joint, that becomes more difficult to do. I'm putting more heat on the bottom bracket shell here. The shell's quite a bit thicker. These aren't very thin chain stays. These are, I think they're 0.8 millimeter, which makes a good touring chainstay for a small person, which is this person's situation. Okay, one more tack here. You probably noticed by now, if you've done any silver brazing yourself by this time, a lot of this stuff falls on the floor. So always make sure to kind of overflux the area due to all the flux that you'll lose. Remember, avoid any red in your metal. If you're getting red during your brazing, you're getting too hot. There we go, it's pulling it right in. Nice job pulling it right inside there. We got a good sized tack on both sides. Okay, now the frame can come out of the jig. You can go ahead and pull the frame out of the fixture fairly soon after you're done brazing. Don't forget, Henry James offers a really nice fixture. His will build rear triangles for you. It'll build front triangles as well, and it'll do forks. Nova sells the Nortac jigs. There's a whole series of jigs that they sell. It'll do all the jobs also. If you want to build your own jig, I have plans for most of these jigs in my latest edition of my book, which is available through Henry James and United Bicycle Tool Supply. We're going to let this cool for a few minutes, and then we're going to stick a rear wheel in there, and we'll see if we have to pull a chainstay in or out to get that wheel to center between the chainstays. Let's put a frame building wheel inside the frame. This one is 135 hub width, 700 by 38C tire, which is what the customer has requested. We'll tilt this up so you can see it. Right here you can see smaller gap, bigger gap. So that means that this wheel is too far over that way, which also means that this chainstay is a little bit longer than this chainstay. So what we're going to do is I'm going to heat up the tack on this side while I'm pinching the wheel against the other chainstay, and that'll shoot that chainstay in a little bit. And we'll hope we hit it on the first shot. Sometimes it takes 2 or 3 shots to do this, and we still may end up pulling dropouts later. When you're doing this, obviously you don't want to aim your flame toward the tire. You're going to cook your tire. We're heating up this tack. I'm also giving a little bit of pressure between the tire and the left chainstay. Now I want this tire to move over about 2 millimeters, which means I'm going to move this just a tiny amount down here. Alright, we're going to give this, it looks really nice right now. We're going to give this a couple minutes to cool so we can inspect it with everything at the same temperature. We're finishing up the bottom bracket joint here. I've been successful at pulling the chainstay in and out to get it to be the right length with the other chainstay. So my wheel sits center now. I may later have to pull a dropout as well to fine-tune it. Don't forget your bottom bracket shell is quite a bit thicker here, So keep majority of your heat on the shell. Remember, our tack is on the top, so we're going to finish up on the bottom here before we go back and finish the top. We want to look up inside to see if we're coming through. Silver is coming through quite nicely here. Remember, add your silver on the outside, pull it through till you see it coming through on the inside. Do not add some silver on the outside and then later add some silver on the inside. If you do that, there's no guarantee if there's any silver in the middle. Got a little bit of a blob here, so we're going to have to heat up over here to pull that blob away. Maybe use a little bit of gravity to help us. And it's starting to pull inside. And we'll look up inside. Good coverage. We got silver coming out all the way around the whole joint on that side. The outside looks good. I think we'll pull some silver down toward the bottom here. There's still a little bit in this area that I'd like to get rid of. In this particular joint, if you're having trouble getting rid of silver, just pull it on the inside and pull it into the threads, and that way when you run your bottom bracket taps through, it'll clean that excess silver out of there. You grab a little gob of silver here, or a little gob of flux here that's caught in the threads there. Bring it out here. Now we'll do the other chainstay. This is almost heated to temperature because it's getting a lot of heat from that first joint. So we'll be ready to go here in just seconds. And she's all set. Little tiny bit looser fit on this chainstay. It's sucking the silver in quite a bit more easily. Keep that flame moving. Don't pause in one location. Always keep that flame moving. If you pause in one location on thin wall tubing, it could mean burning a hole through that tube. So always keep the flame moving. Let's take a look up inside. Oh, beautiful penetration. We got silver coming through in a great abundance. I'm going to pull some of the silver back into the socket area. And I can pull it back around to do the top side of the joint rather than add more silver. I'll pull this stuff in. Okay, we're just re-inspecting here, making sure that we have a nice line. Looks good. And back here. Looks good. Good penetration all the way through. Got silver coming out all the way around. Good. Now that we have the rear triangle in place, we're going to start working on the bridges. This is a touring bike, so I'm going to be using a touring type bridge, and I'll explain that in a minute. Let's look at a couple of bridge options though. First of all, this would be for a road racing bike. This one is a little machine piece, square on the ends, concave in the center. It's pre-mitered, drops right into place, and there's a bit of a gap there right now. That's because our chainstays are so long, but if the rear end were shorter, this would be mitered almost perfectly. Another option right here, this is pretty much the same thing, except rather than having square ends, it has round ends on it. If you want to have a little bit more of a decorative look and get a little bit more coverage for your silver, we can put some little teardrop shaped stiffeners on there. And that kind of gives it the professional look there. Now we're going to be making a bridge for a touring bike, and the big thing about making a bridge for a touring bike is to have something that we can anchor a fender to. And I'm just going to be using some straight 1/2-inch tubing, and I'm going to cut that to length. I'm going to have a nice big gap in here. I want probably about 15 to 20 millimeters between the tire and the bridge, and we're going to miter that, and I'm also going to put the teardrop shaped stiffeners on the ends. So let's go over to the vise and start working on that miter. For this operation, we're going to be using a 6-inch half-round file, and again, I prefer a Nicholson. And this is basically, pretty simply put, this is just doing another miter, except the miter is going to be very easy to do because when we finish up, we want the contour of this miter to match the file exactly. Notice I'm filing at a slight angle. I'm not filing straight across like that. I'm filing slightly uphill. That's to make up for the angle of those chainstays as they leave the bottom bracket. You want to make sure that your 2 points on the miter are the same height. If you don't like the loud screeching noise you're getting off your piece, drop it down a little lower in the vise, and you'll find that it's going to screech a whole lot less. I'm probably filing about a 5 to a 7 degree angle to this miter. Okay, looks really good. I'm just going to run that file around the edges to get rid of that sharp burr. No sense in handling something with a really sharp burr if you don't have to. If you want to, you can take a round file and deburr the inside too. And let's go over there and take a look at the next step. This next step is just basically an eyeball procedure. We're going to make a mark there for a rough cut, and we're going to go back to the vise and rough cut it and miter the opposite end. You want to be careful when you put a little tiny short piece like this in the vise. Because of its shortness, you could crimp it quite easily. So I'm not pushing very hard with the saw because I do have this lightly held in the vise. If I push too hard with the saw, I just push it down. And here's our rough cut piece right here. Now I have another vise that I like to work in, so let's kind of scoot the camera over and we'll take a look at this other vise. This is a special little vise I made. I got this at a garage sale somewhere. It's one of those cute little vices that bolts onto the side of a vise or on the side of a bench. And what I did was I just took a piece of aluminum and held it in the vise, and then it was about a 16th inch thick aluminum, and I drilled a whole series of holes down through this vise. So this is the ultimate axle vise, and also an excellent vise to hold tubing, because it won't deform your tubing, these little short pieces. And now we're going to file the other end. Now the real trick here is to keep these two miters in the same plane. One can be twisted from the other. So we're going to check this part way through and see how we're doing for being in line with each other. A little short piece like this being filed like that, you might want to pick it up with a pair of pliers. Okay, close one eye and tilt that thing to see if your miters line up. They're looking pretty good. This particular piece of tubing is kind of handy to work with because it's a piece of seam tubing, and the seam, I'm using the seam right down the front here to help me keep my miters in line with each other. Another little bit of an interesting thing about this piece of tubing is a piece of stainless. Not particularly because it was requested or anything, but it's just some tubing that I happen to have around that is handy for making bridges, which gets to silver solder. Silver solder is some pretty neat stuff in that you can join quite a variety of different things to each other. You can join steel to a piece of brass, or brass to a piece of gold, or a piece of silver to a piece of steel, or just a piece of stainless to a piece of steel, or a piece of stainless to a piece of stainless. Just quite an incredible variety of different types of bonds can be done with silver. Okay, let's take this over to the frame and see how we're looking. Okay, if you take a look, you can see we've got a pretty good fit there. There's a little bit of a gap on the front of this side, but let's not worry about that until we put our stiffeners in place. So we're going to put these, we're going to pre-assemble this whole thing. And three pieces like this usually tends to like to fall on the floor and run and hide afterwards. And one thing that's important is to hammer these into place, because the stiffeners are not going to form to shape until you put some pressure on them. The only real reason I'm doing that is to get things to hammer into position and go to the right shape. I do have too acute of an angle on this side, so I'm going to clean that side up a little bit. So I'll go back to the vise and then we'll set this up again. Alright, we've got the miters cut so that they're looking pretty good. Now we're going to put the mount for the fender, which I just use a water bottle. And so we're going to punch this right in the middle with the automatic center punch. Double check it. Okay. And I'm going to do a pilot hole first. Now, the first time I went through with about a 7/64 bit. And now we're going to open that up to the right size for a water bottle fitting. Now we have in the forward portion of the bridge a small air hole, and in the back portion of the bridge we have a larger hole for a water bottle fitting. We're all ready to braze, and since we're all ready to braze, let's quickly take a look at the fitting that's all fluxed up, and let's look at the brazing fixture. First of all, we've got our water bottle fitting right there, and our bridge down the middle, of course, and we have our stiffeners on the sides here. I've also had to carefully bend over the tips of those stiffeners because they're coming pretty close to the dimple here. Here's the structure that I use to hold everything in place. This is just a piece of 1/4-20 rod, threaded rod. I have a little handle here for doing a quick loosening job. If I have to loosen this in a hurry, I flip that handle over. Just a 1/4-20 nut there. This is a piece of 5/16 by 28 chromoly tubing, and then there's a little saddle right here, and here's some 3/8 threaded rod that's holding the dropouts apart at 135. When you put in a bridge, it tends to make the dropouts squeeze together, so you want to make sure and hold those to where they're supposed to be, or even hold them wider. You might even want to hold them at 140 as you're brazing. So let's go down here and we'll just do our brazing. Notice I'm using a carburizing flame. You want to be careful around those stiffeners. The stiffeners are probably the most delicate part that you're going to be brazing on the whole bike. Very thin. They can overheat instantly. Let's first heat up the bridge, and then we'll drop a little silver right between the bridge and the stiffener, and it'll suck right up inside. Now with these particular stiffeners, these stiffeners were manufactured by GPM, same people that make the nice Campagnolo copy tool set, and a really good mark of doing a good job here is the name GPM is stamped right into that little stiffener, and if you do a really good job, you'll still be able to read that name after you're done doing this. Okay, now we're dropping silver between the stiffener and the frame. Frequently, when you pull these small parts out, if you're very careful about the storage of your brazons and your fittings and so forth, when you pull them out of the box that you store them in, they're all ready to braze. You don't have to do any cleanup. However, if you get sloppy about your storage and those pieces start getting a little bit rusted and so forth, then you've got to go through the whole cleanup procedure on all of your brazons. So definitely have your brazon storage all set up in a nice dry area where they won't be getting rusted while they're sitting there in storage. If you have some of those little things of desiccants, those are those moisture eater-uppers that they pack in electronic equipment. Go ahead and throw some of those desiccants inside those drawers with your brazons. Okay, we're getting nice coverage here. We're flowing right underneath. Both sides are attached. Now they're attached on the bottom side. Obviously we're going to be flipping this over and we're going to do the top side here in a minute. Let's attach the water bottle fitting in the middle. Don't forget that the silver always follows the heat. And the more careful you are about where your heat is being applied, the less trouble you're going to have when it comes to cleanup. Okay, let's take a look here. We're going to finish up here on the top side. Plenty of flux here because it all ran down to this area. We may have enough silver already in the joint. Just kind of float it around and get it cleaned up. Yep, there's enough silver in this side of the joint. All I had to do is just kind of go around with the flame and do a little bit of cleanup work with the flame. On this side, yeah, this side might need a little bit more silver between the stiffener and the frame. And a little bit in the front. Looking good. I think we're going to give a little bit more of a dab of silver on this side between the bridge and the stiffener and our water bottle fitting. There we are, and our bridge is all brazed in place. Here's our bridge all in place, and let's slide this ruler in there, and I can see I've got 20 millimeters above the top of the tire. That gives me plenty of room for a fender in there. One thing that's really important is try to get your distance here the same as the distance for the seat stay bridge, because you're going to find that if one bridge is closer to the tire than the other, the fenders will not have a pleasing look. They'll be eccentric to the wheel when you look at the bike from the side. And if there's one thing you don't want is you don't want a custom frame that doesn't look pleasing. So let's work on the brake bridge, or the seat stay bridge. Let's take a look at some seat stay bridge options. The ones that I have here are all road bridges. This one right here, it's kind of a heavy thing. It's solid. It's made by Chinelli, and it looks kind of nice. You do your mitering here. The real plus of this one is it's very easy to get your miters in the same plane with each other. These are all countersunk or counterboard Allen fitting type bridges, so you can use a counterboard Allen with your brake. This is a very popular one. This is still available from a lot of people. Little square center setup. It's a copy of a Chinelli bridge. And this one has been out of production for quite some time, but you might be able to find some old supplies somewhere. It's a two-piece. You have to braze this piece into the center. This is kind of off-center right now. It takes a little while to prep it and braze it together, but it's a very attractive bridge when you get done. This one is an arrow bridge. It's a straight arrow bridge. So if we look at it, we can see that we have an inline right there, but it has an arrow cross section through here. This is made by Chinelli. This is also an arrow bridge here, arrow cross sections through here. These are nice because they have built-in air expansion holes right there. This one also has built-in air expansion holes. This one at the end right here is made by Everest, and obviously it's a knockoff of the Chinelli arrow, V-shaped arrow design. One thing I don't like about the Everest, however, is when they designed it, they designed the top flat. That might be a nice area to put an initial or something if you want to have it pantographed in, or do some little very minuscule work on top there. I kind of prefer the Chinelli with the rounded top. Let's take a look at the bridge that we're going to be doing. Again, we're going to be using a piece of 1/2-inch diameter tubing with about a 35 thousandths wall thickness. Here again, this is a touring bike. We're not going to be having a brake fastened here. We're going to be using cantilever brakes. It's probably more accurate to call this bridge a seat stay bridge rather than a brake bridge, because sometimes there are no brakes attached here. Also, along with this, we're going to be using a set of stiffeners that'll fit in against the stays. One thing I do with stiffeners, I've done this over the years, I've been able to find 3 different thicknesses. These are my thick ones, these are my thin ones out here at the end, and these are my medium ones in the middle. And I found that what I can do is, if I overcut the bridge, if I size it for the thin ones and I overcut it, I can jump to the medium or the thick ones without having to cut and shape a new bridge. Here we have our whole bridge assembly all assembled. You want to make sure that your bridge is not sitting there at an angle. So if I can just go in here and take a look, it looks nice and straight. On this one, I don't use a jig to hold it in place, because it doesn't have a tendency to creep up those seat stays the way it would down in the chain stays. One thing I do though is I put a wheel in there, and the wheel keeps the spacing right, and it also just gives me a quick eyeball check to see if things are lined up properly with enough clearance. I've got about 2 millimeters of gap above the tire, so the 2 bridges are going to look good together. I'm just going to quickly tack right down the end of the point there, so that stiffener isn't going to move at all anymore. You notice I gave my tire a spin before I started. For obvious reasons, I do that to keep my tire from burning up. And we'll give her another spin. There we are. That bridge isn't going anywhere now. Okay, now I'm going to tack, actually I'm going to finish this side of the joint between the bridge and the stiffener. Give it a fairly big tack and pull it around. Spin that wheel, we don't want to blow out. Okay, now we have to tilt this level. So we're going to take it like this. I can get my best silver feeding in this way. I keep it upside down at first because the taper of the seat stays will let the bridge stay in place much better if the bike is upside down. That angle between the seat stays works with us if the bike is upside down. Okay, on this other side, I'm going to do the part between the bridge and the stiffener first. Give our wheel a spin there again. Got a little bit of a gap underneath this point. Another dab of silver under there to fill that gap. Okay, now we'll work way down on the floor. Just kind of finishing things up here on the back side of the bridge. I didn't mention earlier, but the on the seat stay bridge, I put 2 air expansion holes and I placed them on the underside of the bridge. And this way, they're out of sight. I'll try to show you later where I put those 2 holes. It's a very common place to put them. Lots of bicycle manufacturers put them on the underside of the seat stay bridge. And one last thing, we're going to braze that water bottle fitting in place. Right here, we're going to braze a water bottle fitting in place. Water bottle fittings are probably the easiest thing to ever attach to a bicycle frame. It is just so easy to braze those things in. That's it, we're done. Here's a shot of the underside of the seat stay bridge. Notice we have our water bottle fitting here. Nice thing about that is we can just pierce a fender, just drill a hole through the fender and put a 5 by 0.8 screw right up through the fender, one of those little button head screws, and a really clean attachment for a fender. And then we have on each side 7/64 air expansion holes. One there, one there. Alright, you've probably taken notice already that this bike has integrated bottom bracket guides on the bottom side, but let's just take a couple minutes and pretend we were going to be putting topside guides on here, and let's look at some simple jigging we can do to get those things set up. I've taken a couple of C-clamps here, and maybe if I turn this a little bit this way, you can see that I've taken the C-clamps and I've taken the little cap off the threaded end and I've made it pointed, and then I've taken the anvil end down here and I made it concave so it doesn't mess up the bottom bracket threads. And I simply hold both bottom bracket guides in place with a C-clamp. Get you a better angle here. Right there, just like that. Be careful you don't braze the C-clamp onto the fitting. After this area has cooled right here, then you can take a small hammer and hammer this in till it hits the frame. And then I usually put a little dab of silver between here and the frame to keep that piece from bending up. Okay, now let's tap and face. And also, if you did put these on, then you'd wait about 15-20 minutes for the bottom bracket to cool before you did your tapping and facing. So since we have integrated guides on the bottom side already, we'll pull these off right now and we'll tap and face right now. Remember, I personally put the left-hand threaded tap on the female side of the tap handles. I'll slide this in. You're probably thinking, well, gee, earlier he put a Sharpie mark right there for left-hand thread. Well, now we have a good landmark to go by, because if we run down the same side of this bike, we find that we have the dropout hanger. The dropout hanger is on the same side of the bike as the left-hand thread, so that makes it a little bit easier now. So we're going to put some oil on here. I prefer the rigid oil that contains chlorine. There are some lard-based oils that I don't think are very good at all. I would not recommend them to anybody, especially if you're doing any high-speed tapping or facing or any high-speed machining. The lard-based cutting oils really smell up a room quite badly. I'm not so sure about using some of the water-based cutting fluids. That works fine in a machine shop setting where you're doing high-speed work and you have to recycle or recirculate that stuff quite a bit. But the main problem with water-based cutting fluids is that you can develop some rust going on, and also after a while the water-based fluids can go rancid on you, and that can also smell quite badly. We're going to bury these. We're hitting quite a bit of silver in the threads, and we're probably also shaving off the very end of the chainstay sticking in there. And we're going to bury this right to the top of the flute as we did before. And then we'll back it out. So we're just hanging on by a few threads before we do the other side. About there. This can get to be kind of grueling work, especially if you're brass brazing. If you're brass brazing, you're distorting the shell quite a bit more during the brazing process, and these taps are going to have to do more work afterwards. In a factory setting, obviously, when it comes right down to making the dollars, we really couldn't justify tapping and facing this bottom bracket 3 times. It just wouldn't be economically feasible. So in a factory, you'll find that they'll set the bottom bracket in a jig along with the chainstays, seat tube, and down tube all at once, and everything gets brazed all in one shot. That way there's only one time that you distort it, and there's only one time that you have to tap and face, and only one time to cold set. Save a lot of time in the factory setting, but also when you get done cold setting a factory bike, the different tubes can be wanting to go different directions, and when you cold set that, they'll be fighting each other. Whereas a custom bike made this way, that's cold set one tube at a time, has less of a chance or less of a tendency of the tubes fighting each other. Yeah, we hit some big chunks of silver in this side. This side took a little bit more work. Remember, as I mentioned before, take the taps out at the same time, both sides at once, like that. Remember, the small diameter sleeve here is the left-hand thread. Those of you that have older Campagnolo tool cases, they were kind of nice because they did have a little L marked on that piece. I haven't seen that for some years, so I think that they have quit doing that, which is kind of too bad. Anyway, we're going to run these sleeves in until they hit each other. And when they hit each other, we're going to want them to snug up fairly tight. Before we face, let's take a quick reading here. We have plenty of leeway here. We have a 68.4. When I finish up, I want to be at about a 68. Some people ask, well, what if you face too far? it's actually better to face too much off than to leave too much on. And what happens is if you go maybe a ½ millimeter under, it's no problem because the lock ring that goes on the adjustable side just has an extra thread sticking out, or a half a thread sticking out. But if you don't face enough, that lock ring might not have enough to hang on to. Remember, as before, this cutter only goes in one direction. You don't have to take a really heavy cut if you've got a good cutter here that's nice and sharp. One thing I've learned about this cutter, I don't know why it is, and it's been the case with many Campagnolo cutters I've used over the years. I always turn the cutter on one side. They seem to cut better that way, rather than turning this way. I have had chatter problems if I turn with both hands. So I just take one hand like this. Okay, then we're going to take and back that nut off, and we're going to take a finishing cut. And let's take a quick reading to see what kind of thickness we have here, what kind of width we have. 68, just shy of 68.2. Okay, let's put this back in from the other side. One thing you'll always notice with any kind of a facing tool is that you always have a high tooth. There's no getting around it. Even when these things are sharpened down to 1/10 of a thousandth of an inch, you still have a high tooth. And we can see here, I don't know if we can get a close-up shot of this, but right in through here, there are no shavings at all through there. But if we look right in through here, lots of shavings, no shavings there. We've got some heavy shavings there. So believe it or not, there's only one high tooth, and actually it's usually only one tooth that's doing the cutting. Even though you've got 20 or 25 teeth there, there's only one that actually literally does the cutting. And it's only cutting by probably a couple 10/1000ths of an inch above and beyond the other teeth. Okay, quick check here. We're gonna look at the surface here. And this surface, we want this surface to be nice and shiny all the way around. When it's nice and shiny, all the way around, we know that bearing cup is going to seat nice and flat against that. Check our width. We are at 67.97, so we're 3/100ths of a minute. Well, depending on how I jockey it, we're running between 67.97 and 68.00. So we're, for all practical purposes, right on the money. That's a 68 millimeter bottom bracket.